Hello everyone. Okay, so this lesson is going to be on how to find horizontal asymptotes algebraically. Now this is going to help you on your Delta Math assignment. Okay, you don't have to take notes. It would help if you did, but you don't have to turn in your notes. Your work is going to be on Delta Math, okay? So let's look at how the Delta Math assignment is going to look, okay? Here we are going to find horizontal asymptotes algebraically. So we have to find all asymptotes in the following function. All right, so to find horizontal asymptotes, we're looking at the highest degree in both numerator and denominator. We're going to compare them. So we have first, if the highest degree of the numerator is greater than the highest degree of the denominator, then there are no horizontal asymptotes. Next, if the highest degree of the denominator is greater than the highest degree of the numerator, then you have an asymptote at y equals 0. Okay, third, if the highest degree of the numerator is the same as the highest degree of the denominator, then we're going to use the coefficients as a ratio, and that's where our horizontal asymptotes will be. Okay, so let's get started with this problem. Now here, we can't simplify. Delta Math is actually going to have you multiply this out. So let's start with multiplying this out. I'm going to do this over here on the side. Okay, so yeah, I'll just use black. All right, so we have this function. And then 3x minus 2x plus 4. All right, so let's do the distributive property on top. All right, so I'm going to rewrite the function. And I have, well, what is 2x times x? 2x squared. 2x times 5. Oops, not 5. Is 10x. All right, and then I'm going to multiply the denominator. And this one I'm going to use the box method. It's a little neat. Okay, so I'm going to put this one on the top. 3x. Over here is minus 2. This one along the side, x. And this is a positive 4. All right, so I'm going to multiply here. Okay, 3x times x is 3x squared. Okay, then I'm going to do negative 2 times x is negative 2x. Let me clear this up so it doesn't look messy. Then I do this one, 3x times 4. It's kind of like a multiplication chart, right? 12x. Then I multiply negative 2 times positive 4, which is negative 8. All right, and then I combine like terms. And I notice that for the most part, my diagonal are my like terms. So here, and I go in descending order. I combine, well, what is 12x take away 2x? Well, that's a positive 10x. And then my constant. All right, cool. So now I look at the highest degree. Well, the highest degree in the numerator is this one, and the highest degree is this one. All right, so then we write this, our horizontal asymptote. Well, how many horizontal asymptotes will we have? Well, this is one horizontal asymptote. And it would be here. You take the linear coefficient. So if I look over here, they're the same. So this is the one I'm using, okay? So that means you use the coefficients as a ratio. So my asymptote would be at y equals 2/3, okay? And that's what you would write here. So you pick one horizontal asymptote, and then here you put y is equal to 2/3, okay? That means if I were to draw this out, 1, 2, okay, 2/3 is maybe about right there. So I would have a horizontal asymptote right here. Okay, so let's go to the next one. I'm gonna still be using this chart. Okay, so let's see. Find the horizontal asymptotes of this following function. So here we go. Now, this guy, there's really nothing that's going to cancel out. So what I'm going to look at is the highest degree in the numerator. Well, which one's the highest? Well, this one's the highest, okay? Because this over here is technically an x to the 0. This is x to the first power. 1 is greater than 0. So this is the one I'm looking at. Then on the bottom, in the denominator, I have a 2. This is to the power of 1. This is to the power of 0. Well, which one is the highest? It's the 2, right? So this is my highest. So then I go here. Well, is the highest degree of the numerator greater than the highest degree of the denominator? Is this one greater than this one? No. Okay, so it's not this one. Is the highest degree of the denominator, is this one greater than the numerator? Yes. So then we have a horizontal asymptote at, y equals 0. Okay, that's all. We just compared them. So this one, we have 1 horizontal asymptote, and it at y equals 0. Okay, I just abbreviated. All right, now let's go to this last one. Oh, look at that. I see something in common here. This might help me out. That way I don't have to multiply it out. Okay, so now if I were to rewrite my functions in simplest form, I would have 2x over 3. Well, what is the highest degree here? Well, it's this one, right? Which is to the first power. This one, well, we don't have anything else, so this is the highest power. All right, so which one is bigger, the 1 or the 0? Well, this one's bigger, right? So is the highest degree of the numerator, is the numerator greater than the denominator? Yes. Okay, because this one is greater than that one. So that means I would have no horizontal asymptotes. All right, now let's check this one more time. If I were, because on Delta Math, they actually tell you to multiply it out. Okay, so let's multiply it out. See if we get the same answer. Okay, let's distribute, distributive property. So now I can rewrite this function as 2x squared, then I multiply here, plus 10x. Then I do the same thing, 3 times x is 3x, and then 3 times 5 is 15, okay? So then which one's the highest degree on the top? So here I have a 2, and here I have a 1. Well, which one's the biggest one? This guy. All right, then on my denominator, I'm going to look. This is a degree 1, and technically this is a degree 0. Well, which one's bigger, the 1 or the 0? Well, that guy's bigger, right? So now I compare. Who has the greatest degree in the numerator or on the denominator? Well, the numerator is greater, right? Up here, the numerator is greater. So if it's greater, no horizontal asymptotes. Okay, whether you use the simplified version or if you multiply it out, Delta Math, it's going to ask you to multiply it out so you can practice it that way. Okay, if you have any questions, send them to me. Bye.